Hey there, welcome back friends. In this video we will move forward and we will discuss about floating point number furthermore. So let's get started. Now friends, in here we have two variables by the name of x and y. The value of x is 1.45, value of y is 2.55, and if we try to add these two values we should get 4.0, and here is the output. Perfect output. Now friends, for example, we remove 0.45 from this variable x. In that case, definitely the output should be 3.55. But there is a catch. The value 1 is a int entity and Java will smartly convert 1 to 1.0. That's magic, right? So we again get a proper output. Now friends, when it comes to decimal points, floating point digits, sometimes rounding off is required. For example, if we try to divide 1 by 3, there is no perfect result for it. Java needs to calculate, needs to round off things. For example, in here, Java has round off the result and given us the result as 0.333333. Now, if we add 0.333 3 times, we won't get a complete 1, right? So in the background, some assumptions, some rounding off needs to be done. Now, when it comes to Java, majority of time, rounding off is done automatically, perfectly. Now, automatic round off is good enough, but sometime it may create some kind of issues. Let me give you an example. If I, for example, add x plus y and value of x is 1.05, for example, then ideally the output should be 3.60, but what we will get? Here is the output. Somehow we are not getting the expected output. What is the solution to it? There is something known as BigDecimal. Let me show you. If you Google for BigDecimal in Java, you will get a Java doc link by oracle.com. Click on this link and this class will give you extra precision, and this will definitely give you tools which will help you to calculate decimal digits with a higher precision, and you have tools which will help you to control the calculation furthermore. I urge you all to definitely check out this and take a note of it. When it comes to ultra precision calculations, BigDecimal class is very useful. So in here, for example, I make use of a BigDecimal and create two objects like D1 and initialize this with, for example, 1.05, for example. And let me copy this particular part real quick and paste it in here. Let me create yet another object by the name of D2 and I initialize this with 2.55. Now BigDecimal help us to provide ultra precision. So should this fix our issue? Will we get a better precision? In fact, the problem will increase furthermore. Let me show you. Oops. In order to add D1 and D2, we need to use a method by the name of add. Let me do it. Now, if we check, the issue increased furthermore, right? There is a trick to end this issue. The solution is use a string version of these variables, these values. What happens is, if we make use of a string version, then rounding up will be disabled by default and we will get a proper output as 3.60, which is a good thing, right? So in order to disable rounding off, this is a quick trick, but furthermore you can definitely research more with this BigDecimal class, and there are like many tools provided like ceiling, rounding off, scaling, then absolute value, then things like that. So definitely a useful class, and definitely I urge you to research more on BigDecimal. Alright, so this is it. This is a quick video on how we can handle decimal point values furthermore, and a small little trick to disable the rounding up issue with Java.